In the distant cosmos, an unknown future where anything is possible. So of course we're still blowing each other up. But remember, in space, no one can hear you scream about how scientifically inaccurate that space battle is.
Why am I blasting through the cosmos at full afterburner?
An object in motion stays in motion unless acted upon by an external force. So that means if I'm moving, I'll keep moving in the same direction even with my engines off. Real space fighters would probably only engage their engines for short bursts to speed up or slow down or maneuver. But how would I maneuver?
Use the Force. Literally.
Obi-Wan Newton, is that you?
Let go, Joe. Ask yourself, does any of this actually make any sense?
Well, a spaceship in motion has momentum, so to move in a different vector, a force has to be applied to counteract that momentum. And today's spaceships use steerable thrust to orient the ship in 3 dimensions.
But maneuvering thrusters would be vulnerable to enemies.
What if they used internal gyroscopes near their center of mass? Then they could harness angular momentum to orient the spacecraft and apply bursts of thrust to accelerate.
This sounds familiar.
What about weapons? I mean, in space with no atmosphere to create a shockwave, explosive weapons are kind of useless. And do I even need to say it?
No sound in space.
Nukes! They could still deliver blasts of radiation energy. Their intensity would decrease with the blast radius, but within a few hundred meters of a spaceship, they could spontaneously melt a metal hull to liquid.
Neutron radiation could pass straight through spacecraft armor.
It could radioactively cook any humans inside like stormtrooper hot pockets. But missiles and guided weapons suffer from the same Newtonian limitations as we talked about before.
Lasers!
Real high-energy lasers would be invisible since they operate outside the visible range of light.
But remember, over long distances, lasers are difficult to focus.
It's true. Lunar range-finding lasers that are fired from Earth at reflectors on the moon are over 6 kilometers wide by the time that they hit.
But don't forget energy. A weapon like the Death Star is equivalent to all the energy released by the sun in an entire week.
There's no atmosphere to dissipate all that heat. Honestly, if you want to destroy a planet, you're probably better off throwing an asteroid at it or something.
Heavy thing moving fast makes spaceship go boom.
A different battlefield calls for different tactics.
In space, there is a great deal of space.
Close-in broadside naval battles look cool, but not gonna happen.
In space combat, the speed of light could be our greatest advantage.
It's true. If Earth's orbital defenses are engaged in battle with the rebel Europa colony, each side would be firing at each other's shadow. Because of the time it takes light to travel, they'd only know what the other was up to like a half an hour earlier. Well, in some ways, realistic space combat would be closer to the 18th century than it is today. Imagine days-long communication delays, battles that are fought with cannons and musket balls, except it's happening in space. It makes you wonder, why is so much of what we see so wrong?
Like Jar Jar Binks.
Right. It's George Lucas's fault. The ship-on-ship combat of Star Wars, which has got to be the most influential space combat fiction out there, was actually based on World War II dogfighting, like take the attack on the Death Star, based on a British World War II film. And most space battles haven't reached past his prototype.
Why is the inevitable outcome of human space exploration war?
I think that says more about our own fears and history than anything else. A lot of 20th century science fiction was warnings about 20th century wars. And in reality, space combat is just so impossibly difficult and deadly and impractical that it's worth wondering if we'll ever actually see it come to pass. I say we take a nod from JFK.
But I do say that space can be explored and mastered without feeding the fires of war, without repeating the mistakes that man has made in extending his writ around this globe of ours.
And if you subscribe, I will spare you the firepower of this fully armed and operational YouTube channel. Well, listen, lots of very smart people have spent lots of time writing lots of words about this very subject. Put lots of links down in the description for you to check out and discuss. What do you think? What will space battles look like in the future? Will we even be fighting in space? And do any of your favorite books and movies get the physics right? Let me know down in the comments.
Stay curious. Always.
The most dangerous animal on Earth isn't the shark, the lion, or even the hippopotamus. It's so small, in fact, that it could sit on the tip of this pencil. Biologists estimate that it has killed nearly half of all humans ever born, and today accounts for more than 45 million years of lost human life.
Intensify forward fire power!